Okay, hello. Look, we are live. Hello. Hello, hello. You got everything that we need today. Yep, we got everything that we need today. All right. Waiting for people to chime in. Definitely need volunteers today. All right. Someone needs to say something in the chat. I got a couple more minutes. Wait for people to come in. Hello. Hey, PBO. What do you want to ask about? I was connecting headphones. Okay. Yeah, since you got headphones, PBO, good to see you. All right, audio check. How do we sound? Since you're in a headphone, how do we sound? Check, check, 1, 2. Check, check, 1, 2. Check, check, 1, 2. Check, check. Hey, Frog. Okay, good. Check, check, 1, 2. Check, check, 1, 2. Check, check. All right, now video. Get the light on. Hey, Frog. Okay, I'm gonna need the both of you. PBO SCO1. Cool. Yeah. Yeah, recently I'm going down the road. Speaking of headphones, I'm going down the road of using gaming headsets now. Because the speaker I had has connection problems. Yeah, it's quite amazing. Where have I been? Yeah, gaming headsets are pretty damn good now. All right. Anyone else? We got chimed in. Okay, we get the audio. We're going to start in 1 minute. Definitely a dense topic today. Yeah, so one that I think a lot of people look forward to. Yes, yes, it's a topic that a lot of people look forward to. Yeah, all right. It's the one that everyone looks forward to in terms of cracking passwords. Yeah, some people may see some parallels with cracking passwords and cryptocurrency as well. Anyone else who's on today? Okay, it is now 4:30. Hello, everyone. Hello, we are on. I'm Ming Chow, Associate Teaching Professor at Tufts, and this is Introduction to Security. It's now October. Hey, Coram. It is now October. Yeah, so October means a number of things. Well, for this year 2024, October is Breast Cancer Awareness Month. It is also National Cybersecurity Awareness Month. So happy hacking. This is also an election year, and historically speaking, this is where a lot of this is the time where hijinks happen. Yes, lots of hijinks. And hey, what a way to start off National Cybersecurity Awareness Month to talk about passwords and password cracking. All right. So, that is the gist of today. Is going to be passwords, the wrong way to store passwords on a system, and password cracking. Hey, Messi. Okay. So, let's get to it. Now, as you know these days, you can't read the news about some system or company or institution getting breached or attacked. Okay? So it's now not a matter of if a company or an institution get breached or attacked, it's just a matter of when. So let's say that a company or institution got breached and the attackers dump the entire database of users. I mean, this stuff is pretty common. Hey, um, you can play a game of when was your password lost? When was your social security number lost? And it's like a daily occurrence now. So that's why I say, hey, it's a matter of when, not a matter of if anymore. Hey, Bot Ranger, how are you? Okay, so let's say for the sake of argument that a database at an institution or company gets breached. And well, this is one of the database table, database table of users. And this database table of users is going to have a couple of columns, username and password. Okay, so imagine, again, this is a fictitious company or institution that got breached. And this information just got into the hands of attackers. So we're going to do Bot Ranger 24. I'm going to give you a password of apple juice. I'm going to just make usernames and passwords up. Okay. I'm going to have messy dependency. And the password is okay, we got messy dependency column. And your password is, we're going to say it's called, let's do okay, who else are we going to do? PBOSCO1. Your password is going to be, I will give you the password one. Anyone else? Who else is on? Anyone else? Anyone else? Okay. All right. Okay, we got Mr. Fish. Okay, we got a whole bunch of people here now. Yeah, your password is also going to be whatever 1 2 3. Yeah. Okay. And we're gonna say SoCal Nila. Your password is going to be password 1 and DS worst student. Your password is going to be 23 and me needs to pay you. Let's make something up. Okay, this is good enough. This is good enough. So again, fictitious company or institution gets breached. There's a data breach. Attacker gets a database of data, get a database of records, and hey, very common to find a user's table, of account information in the database. So here we go. So we have a list, we have a database table of usernames and passwords. Hey, Luppy, I will add you as well too. Why not? Luppy, we're gonna make a password for you is password 1. Why not? Okay, so this is just plain bad. Okay, if an attacker gets his hand on this set of information, you tell me what is wrong. Like, this is wrong way, number 1, to store account information, username and passwords, on a system. What's the obvious problem or problems? Okay, this is obvious now. Like, what are the obvious problems? Okay, yeah, I mean, number 1, everything is in plain text. Username is in plain text. Well, that's not the issue, but it's the password. The password is in plain text. It's unencrypted. Okay, use password as plain text, password as plain text, but there's also another one. Herb. There's actually another problem as well too. Take a look at the passwords. Can anyone notice something now? Hey, because everything is in plain text, what else do you also notice? The passwords are in plain text. What do you notice? This is just pretty bad. I mean, unfortunately, it's also very common as well too. It's yeah, we have not one, not two, but three accounts that use the same password. Okay, PBOS call one, SoCal Neela and Luffy all use the same password, password one. I mean, yeah, number three, password one is also bad. So you got three problems here. Okay, this is just plain bad. This is not, if you're building systems or you're storing username, password, you need to do that. Don't store everything in plain text. Come on. Unfortunately, it still happens. Okay, this is wrong way number one. Okay, yeah, exactly. Common, don't have a mixture of. Well, that's another thing as well. We'll get to that thing about the commonly used. Like, yeah, that's another conversation too. So, can we do better? Is there a better way to store, especially password information? Instead of just everything in plain text? And the answer is yes. Okay, we're going to go a step up now. We're going to do something better. Now, instead of storing the plain text password, we can actually store something called the cryptographic hash of the plain text password. Okay, so what a cryptographic hash function is a function that takes in some input, in this case as a string, and it provides some output. For those of you who have taken data structures before, I hope that you have learned something called a hash table. A hash table is used for searching, like really quickly, constant time searching. Okay, also, hash tables are used more often than you think. I mean, hash tables, hash maps, distinct associative arrays, finite maps, dictionary. Some of the best data structure around. But one of the important things about hash tables is the use of something called a hash function. Now, let's have a quick review of data structure. What are the important properties of, theoretically, for an ideal hash function? What are the four properties that a hash function must follow? Okay, there are four properties of hash functions. Okay, anyone? Do you remember? You gotta know this. Same input, same output. Always. That's number one. Ooh, one way. Not reversible. No decrypt. There's no decryption. Okay? The other one is no collisions. That's the biggest one. And one more, which a lot of people, generally forget, is uniform distribution. So what does that mean? Random. Not predictable. Because if something is too predictable, then hey, that can be just easily broken into and hacked. So this is what a cryptographic hash function, the properties of cryptographic hash function. Okay, they're hash functions that takes in an input, give you an output of some sort. Okay, one way, no collision, uniform distribution. These are the important properties. Now, what I'm going to do now is I'm going to go and use MD5 Calc. Okay, this is a website that actually has a whole bunch of cryptographic hash function that you can try out. Okay, there is MD5, there is SHA-1, SHA-256, SHA-512, there's a whole list of them. Okay, in this case today, why don't we use SHA-1 as the algorithm? So let's do the SHA-1 of baseball, the string baseball, lowercase b. And that is the baseball is the input. The output is this hash or this key starting with A2 all the way ending in 362. Okay, now what about football? Okay, the input is football and the hash result is 2D yada 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 2D8. Now, case matters. The little things matter. Once you change a character, it's gonna screw up. It's gonna change the key. So if it's uppercase baseball, it's not gonna be the same as baseball all in lowercase. So in this time, the input is baseball with a capital B. The hash value is EC yada yada A8. Okay. So now you also notice that the hash keys, okay, the hash keys, these values, they're the same length, okay? What's also interesting and what MD5 calc does for you, okay, is that the string baseball, all lowercase, is encoded to other algorithms. Yeah, it actually computes the MD5, SHA-1, SHA-256, SHA-512 value. And as you can notice something is that, if the bigger the number that you get to SHA, the length is a lot longer, the length of the hash. And that actually matters quite a bit down the road. Okay, MD5 is really, really old and it's also very short. SHA-1 is what we have here, what we've been using. SHA-256 now is what, the baseline which people can use, like should use, all right? But let's go back here and let's actually now do the SHA-1 of each and what we're going to do now is we're going to take the SHA-1 of each and every plain text password. And instead of storing the plain text password, we're just going to store the SHA-1 hash. Let's start off with apple juice. Instead of SHA-1 of apple juice. Okay. All right. The SHA-1 of Perl is a terrible language. Okay. We're going to do the SHA-1 of Stardew Valley 1. I really need to play that game. I'm getting sick of Animal Crossing. SHA-1 of Password 1. The SHA-1 of whatever 123. The SHA-1 of password 1. Didn't we do that already? The SHA-1 of 23andMe needs to pay you. Alright, so far no collision. That's good. We will hit the jackpot if we actually find a collision of some sort. And of course, password 1 again. Here we go. Alright. Okay, alright, here we go. So now this is a step up. This is a step up. Okay, so vast improvement this time. Okay, vast improvement. Vast improvement. Well, first and foremost, the biggest change now, is that the password field, the passwords, are all Well, they're no longer in plain text. But you have a couple of problems. Okay, the biggest complaint, the biggest problem is that is gone. Password is no longer in plain text. But there are a couple of really bad problems that remain. What are they? The username is still in plain text. That's fine. I mean, that's absolutely necessary. Believe it or not, you in fact do need the username matters not so much because in fact a lot of times username need to be in plain text because of so many different system functions. Okay, yeah, the biggest problem, like if you're going to use like system things, like for example sudo, you need to check for username um, really quickly. So username really have to be in plain text, especially for functionality reason. But here's the problem: there's actually three problems. Actually, you all noticed three. Okay, there's nothing wrong with the length of the passwords now that are stored in a user table. But there is a serious problem with, you notice there's a pattern. Okay, pretend that you didn't know that E38 yada yada 3D is password 1. You have three usernames that have the same exact hash output. What that means is, okay, well, again, pretend that you didn't know that this was whatever, like that's whatever one. This means that three people are sharing the same, yeah, using the same exact password. Now that's bad. I mean, now you know of a pattern. Okay. Number two is that the passwords are not salted, and that is ultimately the reason why that you can still see three accounts use the same password. We'll get to what a salt is next. Um, but number three and number four, people out there have already done a pre-computed the MD5, SHA-1, SHA-256, yada yada yada, of all the dictionary words, or what, 26 to 30,000 dictionary words out there. I mean, that list is already pre-computed. So, for example, although you know that you cannot go backwards in cryptographic hash function, but if I take, for example, a very common one is 2D27, this one. Let's take the hash for football. While you can't go backward in cryptographic hash function, you can do a Google search and you can just search the hash and it's going to bring back, I mean, the cryptographic hash of all like dictionary words and common password, that's already pre-computed. So someone out there, can just look this up using Google. So while you can't go backwards, there's no decrypting cryptographic hash functions. It's really easy to see the hash values of dictionary words and common passwords. Okay, there's also another big problem that no one. Yes, that's rainbow table. If you crack one, now you have access to three users. Exactly. But there's another one. There's another one which actually I'm surprised no one has actually mentioned. SHA-1 is already broken. In other words, they've already found collisions in SHA-1. Yeah, I kid you not. Yeah, this was done not too long ago. Believe it or not, this is like 16 or 17. This happened, 2016 or 2017. Shattered. And this SHA-1 was broken by Google. They broken this, and the cryptographic hash function standard is used for digital signatures, passwords, yada yada yada. And they actually provides a proof now it is practically possible to craft two colliding PDF documents and obtain a SHA-1 SIG digital signature on the first PDF file, which can also be abused as a valid signature on the second file. And they even have provided an example of this. There you go. Two PDF files, PDF1, PDF2, and they share. Oh, and I think I have to blow this up. Hold on. I'm gonna take a look. Here it is. Yep. Two different PDFs. Same cryptographic hash value coming out of it. So let's take a look. This is the infographic. A collision is when two documents have the same hash fingerprint. This is not good. Not good. Okay? What gets impacted? A whole bunch of things. Namely, Git was a big one for years. For years, Git commit messages, Git commits, not messages, Git commits were the identifier. Use SHA-1. But here's the thing. While you should worry, you should worry that SHA-1 is no longer, quote unquote, the best one out there. It's broken. It does take a long ass time to find a collision. Yeah. MD5 takes really quickly now. Shatter took like 1 year using 110 GPUs. If you do brute force SHA-1, it takes 12,000 GP, 12 million GPUs in 1 year. Cool. Okay, and your defense, use SHA-256 or SHA-3 as a replacement. So, yeah, SHA-1 is broken. There's a multitude of problems here. All right, so now let's do this all over again. Let's go all the way back. All right. Now this time what we're going to do, all right, now we'll do it the correct way. And the correct way is, okay, before we do the hashing, why don't we append or prepend? Doesn't matter which one. In this case, we're going to choose prepend, append to the end some sort of a random token. Let's say 2 letters. Some random. Now, again, this is quote-unquote random. I'm just pulling out of my head right now. This is as random as you can do. A token, in this case, is going to be 2 characters, a alphanumeric. Okay? Now, pretend that the token is random. In this case, okay, in this case, token is a random alphanumeric string, 2 characters. And what we are going to do now, okay, is before we do any hashing, we will append the plain text password with the token. So we're going to use, let's use SHA-1 again. Oh, let's not use SHA-1 because it's broken. But let's in this case use SHA-256 because it's a lot safer to use and it isn't broken like SHA-1. So let's do apple juice and AA, 2 A's. There we go. And you can see that the string is a little longer. Ooh. Just want to make sure everything's in one line. Can I do this? Oh no, I can't. Okay. Perl is a terrible language. Prepend a BB at the end of it. Here we go. Stardew Valley 1, C1. Oh, 256. I feel like I could still do this in SHA-1 and not SHA-256, but I don't want to be a hypocrite. G4 is the token for the first password one. Whatever 1, 2, 3 and BC. Password 1 and DD. #23andMe. Ooh, look at that. Nice. 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 And Luffy is password 1. Look at that. We are now done. Okay. Here we go. How to produce a collision. Okay, can I elaborate more on how to produce a collision? So, you know what a collision, okay, so a collision is when two different files or two different things actually provide, have the same cryptographic hash. So here's the deal. How can I produce one? I can't. I mean, they have to do a whole bunch of things behind the scene to do that. I'm not in the business of creating producing collision. I've never done one before. Google has, and they created. Actually, I don't even know like how they created PDF file, two different PDF files with the same collision. I don't. I don't. Okay, but going back to this example here, like that's a good question, Bot Ranger. Like I don't know how to actually do that, and it takes a long time too. Okay, so now in this users table, all right, this looks a lot better. First of all, the passwords are no longer in plain text, and the second thing is, well, I can't tell if anyone is using the same password, and that's important. This looks good enough. Okay, if I do a Google search for, let's say, this password hash for worst student, could I find something? I'll be very hard pressed. Nothing. Okay, so hey, we can't look something up as well. So this is actually really good. This is actually pretty damn good. Now, I've been using the word token. Okay, I've been using the word token for the last, 10 minutes. So the whole point of a token, all right, is to make the hash a lot more random. But there is a formal term. There is a proper term for token. And it's not called token in the real world. It's called a password salt. Okay, so a token is a password salt. And the password salt is a random alphanumeric character. It's very short usually to actually make the hash look really, really different than all the others. And there's a really good Stack Overflow post on Salting Passwords 101. Alright, so this is how salting works. Okay, can someone actually elaborate how salting works? Okay, so here it is. And so salt is combined with the password before hashing. The password and salt clear values are concatenated and the resulting string is hashed. This guarantees that even if two people were using the same password, you would have different hash result. Also make attacks better known as dictionary attack using rainbow table much different. The salt is stored in original clear format along with the hash result. Now, if you're building a system, how you check password is, hey, then later if you want to verify the password, you would do the original process over again. Combine the salt from the record with the password the user provided, hash the result, compare with the hash. And there you go. Yeah, so password salting. Yes. And so this is the proper way to store passwords on a system using the idea better known as a salt or a random, token, alphanumeric token string. So now with this said, now where are we going to use this? Is this, just the way that systems actually store usernames and passwords and account information? And they say, yes. Yes. You're building web apps, this is the way. But also, if you're using a Linux system, all right, this is exactly how account information and passwords are stored at the system level. I kid you not. In fact, let's do one out. So I have my home lab open today. I have my home lab turned on. I'm going to SSH into dirty work. Okay, this instance of my Linux system at home is an Ubuntu 24.04.1 long-term support. Okay, so now what I am going to do is I am going to create a couple of users. I'm going to use a few volunteers. Okay, I'm going to sudo add user. Oh, let me get a pen just to make sure. Alright, Bot Ranger 24. Okay, so I'm going to do Bot Ranger. I'm going to create a brand new user called Bot Ranger. Right now there's only one user account on the system, that is dev. Okay, sudo add user Bot Ranger 24. Okay, Bot Ranger's password is going to be that information is correct. Yeah, let's do 5 accounts today. Alright. Yeah, I'm just writing down some passwords so we don't forget. The next account watching like, okay, you kindly asked not to be volunteering. Okay, if we will be SSHing later. No, you won't be SSHing later. So, I'm not going to use you. I'm going to use Luffy. Luffy, your password, I'm going to make something up. You're not going to SSH in the system, but we are going to break these passwords. I'm just going to say, anyone want to take a guess what Luffy's password is? Take a guess what Luffy's password is. I just made something up. Sudo add user Misra Fish. And your password is going to be... Anyone want to take bets what the password I gave to Misra Fish is? One Piece? Where do you get that from? Oh, PBOSCO1. No, let's go SoCal Nilla. SoCal Nilla, your password is... Starfish. Yes. And we'll add one more. Ooh! 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 Worst student. Okay. Interesting. 6 characters. Ha! Are we sure about that? You think? Well, let's see. Okay, so we created 5 user accounts. Including Dev, there's going to be a total of 6 on this system. Okay, so I'm going to clear the screen. I'm going to do an ls/home now, and you can see there's a user account for Bot Ranger, myself, Dev, Luffy, Mr. SoCalNilla, and Worst Student. But we created 1, 2, 3, 4, 5 brand new accounts. So you may be wondering where the username and password hash is stored on a Linux system. Okay, usernames and passwords are stored in a file called in the /etc folder, in the /etc directory, do an ls, and the file is named PASSWD. More PASSWD. Here you go. This is a list of all the account usernames and passwords. There it is. There it is, folks. As you can see here, there is an account for, this is BotRanger24's username and password, Luffy, Microfish, SoCalNilla, and Worst Student. There you go. Whoa, 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 wait a minute. Whoa, 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 whoa. I don't see the password hash. Whoa, 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 whoa. Where's the password? Where's the password hash? Well, back in the ye good old days, like 2000 and prior, username, account username, and password hash was all stored in one file, /etc/PASSWD. Ah, damn it. The password file used to store everything. So, hey, back in the days, if you actually broke into a system and you just took the PASSWD file, this contained all the data. That's bad design. What they ended up doing was the password hashes got separated out into another file. But you still need the PASSWD file because that's the file that the system uses quite a bit for all sorts of account transaction, anything like logins and all that stuff. But the password hash is stored in another file in the /etc directory, better known as the shadow file. Here, the shadow file is here. Shadow. So if I do a cat shadow, ooh, permission denied. Sudo cat shadow. There. Okay. Now, here we go, people. The username and the password hash and a whole bunch of information. Can I paste this in the chat? I think I can. There you go. Looks like that. That's the shadow file. That's the shadow file. Take a look. Really? Okay, we know BotRanger24, Luffy, Microfish. That's the username. But this next thing, the next entry after the colon, that must be the password hash, right? You got it. But how the hell you read it? It starts with a $Y $, and then something something $. Okay, we'll tell you how to read it. Let's read and understanding the shadow file. Okay. shadow files. There are several different authentication schemes that can be used on Linux system. The most common one is to perform authentication against a /etc /passwd and /etc/shadow files. The shadow file is a text file that contains about the system user's password. It is owned by root, so you have to, in order to read it, you have to do sudo. So here is the format of a shadow file. Yeah. The pasting of the hash on the chat didn't work. Yeah. Hey, Snoozer Kyle. Interesting. Interesting. That is weird. Wow. No, I see it. Okay. The pasting of the hash on the chat didn't. Interesting. Well, and anyway, so each line of the shadow file contains the common value of the values. You start with the username, the encrypted password, last password change, yada yada yada, all the way to unused. So there's 9 fields. So here is how the encrypted password, what we're really interested in is the encrypted password. The encrypted password, the password is using the $type $salt $hash format. Okay? So what we have here follows that format. $, this is the hash function that is being used. Yeah, the $type, the type is Y? We'll get to that in a few moments. $type $. This is a salt. Cool. And this is the hash, all the way up to the colon. Yeah. Is it? Something like that, okay. So it's like $type $salt hashed format. Now, what about type? The type is the cryptographic hash algorithms that is used. $1 is MD5. That's like really old system. $2A is Blowfish. Do we see $1, $2, $5, $6 here? Nope. We have $Y. We'll get to that in a moment. $5 is SHA-256. $6 is SHA-512. Well, I see a $Y. What in the world is that? The newer system within the last 5 years moved to a changed cryptographic hash algorithm. And it used to be $6 was like 5 years ago was the way. Now it's $Y. What in the world is $Y? $Y is called YesCrypt. Okay, it's the newer standard that is used today. YesCrypt. Okay, and this talks about what we just talked about is they're using /etc and /shadow. And YesCrypt, how does YesCrypt actually work? Okay, $Y, here it is. $6 is SHA-512. $Y or $7 is what is called YesCrypt. Okay, the whole field now it changed a little bit. It is $ID, $param, $salt, $encrypted. Interesting. The whole format becomes more okay. So here it is. Critically, as of this writing, YesCrypt with its context and tree yada 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 is widely adopted and a default password hashing scheme for many recent versions of major distributions. There's another file of how YesCrypt password Linux. We got anything good? Let's talk about a format. Here it is. So is the Y and the dollar sign, the first Y that you see, and after the first dollar sign is yes script. Then I think that's the type, param, salt, and hash. So format is $ID, $param, $salt, $hash. Okay. And explain more details here. The param is the name and its value hash complexity parameters like rounds, iterations, yada yada yada. $sign Y is yes script. Okay. J9T. Cool. Okay. We'll talk more about the password cracking competition, but I only do up to $6 because that certainly is supported on Mac OS for password cracking. Okay. So now you understand how user account information, the username and password hashes, are stored on modern Linux system into files /etc/passwd and something and /etc/shadow. You need those two files. So now, what do we do next? It's the time that we are waiting for. What is BotRangers24's password? What was Luffy's password? Oh, Mr. Fish. What about SoCal underscore Nilla? What about War Student? Anyone want to take a guess what their password is? And are we so sure that SoCal underscore Nilla's password is 6 characters long? Well, let's find out. We need to crack the passwords. Okay, so how do you do password cracking? Okay, how you do password cracking is, I'm going to cover, there's a number of password crackers out there, but the two most famous ones are John the Ripper and Hashcat. I like to use John the Ripper for teaching purposes because you are forced to understand how on Linux system user account information is stored in the /etc/passwd file and a /etc/shadow file. I want to introduce you to John the Ripper now. John the Ripper. John the Ripper is free, it's open source, and it's largely platform independent. Go to openwall.com.john, and John the Ripper is an open source password security auditing and recovery tool available for many operating systems. And I say this all the time, any security tool can be used for both bad and for good. For years, system administrators used password crackers like John the Ripper to audit the password strength of accounts. We do it all the time at Tufts. In fact, Michael Bauer do auditing of passwords on Tufts CS, and he runs a password cracker and finds out if someone's using like ABC123 as a password or password 1, you're going to get yelled at. Okay? So, John the Ripper is used for what is designed for good. Of course, password cracking can also be used for bad, such as when you break into a database, steal the whole bunch of credential hashes, you gotta break them. Okay? So, John the Ripper, how you use it, well, we'll do that right now. If you're on Mac OS, I'm going to open up a brand new tab. How you install John the Ripper is the following. Ideally using Homebrew. Brew install John-Jumbo. This is how you install John the Ripper on Mac OS using Homebrew. I already got it installed. Okay, to reinstall it, let me do a brew info, John, Jumbo. Okay, this is the enhanced version of John, a Unix password cracker. Okay, I already have it installed. You can install it on any system, like in Linux, So I'm going to fire up another terminal here, and I'm going to log into my instance of Kali Linux that is running. So if I type John, oh, got nothing. Can I do an unshadow in this thing? Yes, I can. Okay. So what I am going to do now, okay, I am going to go to my home directory, that's clear, ls. I have 3 folders here. The first thing is what I'm going to do is make a copy of the shadow and PASSWD files on this system. So sudo copy, and I'm going to call this PASSWD copy. And I certainly need to do a copy of the shadow file as well too, but I also need to change the file permissions. Okay, so now I have a copy of the password and a copy of the shadow file. Why do I do this? I don't want to mess with the system. Okay, always make a copy of the thing, shallow copy of a file, then you can do whatever you want with them. I don't want to mess with system files. Now the next thing I also have to do, if you do an ls-l, you notice that both files are still owned by root. So I'm going to change the owner of both the copy files to be me, dev. Oh, you can see now that the owner of both the PASSWD-copy and shadow-copy files are now owned by me, dev. Okay, so what I am going to do now is I am going to go to my Kali Linux instance here. And minimize this thing. I got no files here, but I'm going to do a secure copy because this Kali Linux instance has a copy of John the Ripper. So I am going to copy dirty work *copy file into here. Yeah, got them. So now I have a copy. I just downloaded the PASSWD-copy and shadow-copies from this dirty work box. Cat PASSWD copy. There you go. Bot Ranger 24, Luffy, Misra Fish, SoCal Nilla, and Worst Student. Okay. So I'm going to do a cat of the shadow file copy. There you go. All right. So I got both files here. Oh man, John. John the Ripper is a tool to find weak passwords of your users. How you run John is really, really simple. It's a John followed by a password, by something called a password file. Now, just a little bit of a, wait a minute, password file? What is that? We have 2 files here, PASSWD-copy and shadow-copy. Which one's the password file? The answer is none of the above. To create a password file that can be used by John, you need to run a tool that combines both the PASSWD and the shadow files. And John the Ripper has a tool called Unshadow. Unshadow is a tool that combines both the PASSWD and shadow files. How you run it? Unshadow, put in the PASSWD file, put in the shadow file. So what you do is unshadow PASSWD copy, shadow copy, and there you go. But wait a minute. everything's spit out to the terminal right now. Okay, fine. What you need to do, send it out to a file called crackme. We'll call it crackme.txt. Now, if I do a more crackme.txt, there you go. It's a combination of both the PASSWD and shadow files. Now, what I want to do, we only want to crack Bot Ranger, Luffy, Mistra Fish, SoCal, Nilla, and Worst Student. We don't care about the other accounts, like all these system stuff, like MySQL. So I'm going to fire a vim. I'm going to vim crackme.txt. I'm going to remove like all the other stuff. Save. Okay. More crackme.txt. I got Bot Ranger, Luffy, Mistra Fish, SoCal underscore Nilla, Worst Student. Okay. Now, are we ready to start cracking passwords? Okay. Now, all you need to do is run John crackme.txt and hit enter. Oh. This is not good. This is not good. Sometimes you may see an error. I'm going to hit Control C to get out of it. Okay? Now, the problem is, for years, okay, John the Ripper only supports $1 to $6 accounts. Now what we need to do for $Y credentials, okay? For $Y credentials, which is YesCrypt, what you need to do, you need to add one more thing, okay? For $Y accounts, someone asked us, a few years ago, does John the Ripper not support YesCrypt? I was learning about password hashes, and then you'll probably get, and then most of the time you'll get no password hashes loaded. And this was the error I got a bit earlier today. The way to get around this now is you need to actually put in -- format equals crypt, which will use the system's crypt function. Okay? I'm going to copy this and send it all to you. Is it bad that it is taking a while? Well, in this case, it could be. But it shouldn't be that quick. It shouldn't be that bad. Because I know a few of your passwords are really dirt simple. So now if I do John crackme.txt and then the format is crypt, hopefully you can see a bunch of easy ones being cracked. Again, there's 5 accounts on here. Now watch what happens. Password cracking can take a very long time, but it will be. But some of these accounts should take very quickly. And we'll let it run for a bit. Up, 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 up. There we go. Do you see that? Hey, Crumb, did you see that? Okay. So we had 5 accounts. John the Ripper cracked 4 of them right off the bat. Now here's how John the Ripper actually works under the hood. John the Ripper, okay, I'm going to hit Control C for a second. I'm going to stop. Now this is important. If you do a Control C and you quit, don't worry. It's not, and then you run John the Ripper again at a later time, don't worry. Crack passwords, in this case, the crack passwords are Misra Fish, Luffy, Bot Ranger 24, and SoCal_Nilla. They've already been cracked. John the Ripper will not crack passwords that have already been cracked. It's a waste of time. Let's get that out of the way. Again, don't worry about controlling C, because John the Ripper internally will store a part of all the cracked passwords, so it will not crack password that's already been cracked. Again, it's just a waste of time and waste of resources. The second thing is, as you notice here on the screen, it's pretty in faint colors. When you fire up John the Ripper the first time without any word list, by default, it will use its own default password list. Okay? So in this case, as you can see, the password list that John the Ripper has is stored in /USR user /share /John /PASSW password.lst. So if I do a more /user /share /John password.lst on my Linux system, on Kali Linux system, here. And this is the default word list. That is built in to John. That's built in. That's used by John the Ripper. How many words is this? It's actually tiny. 3,559 words. That's like nothing. 3,559 words. Okay? But let's go back. So, Misra Fish's password was password 1. Luffy's password was ABC123. Bot Ranger's password was elephant. And SoCal_Nilla, indeed, it was 6 characters. It was just 987654. Yeah, indeed, it was 6 characters. And these are just weak passwords. But worst student's password has not been cracked yet. Worst student's password has not been cracked. I don't think it's on here. Well, I don't think it's on here. Nope. Yeah, it would have been too easy if it was ship. So, how do we crack worst student's password? I'm going to clear the screen. Now, once John the Ripper, I can hear this, I'm going to restart. Remaining 1 password hash. Proceeding was the password.lst file. Now, it's once John the Ripper goes through its default PASSW password.lst file, it's going to do brute forcing. It's just going to use like random numbers, random characters, and try to find it that way. Okay? It's almost done with the word list. But the best way, by far and away, to crack passwords is using word list. Is Pat looking up password hashes with it? No, it's John the Ripper looking up password hashes with his own ls list file. Yeah, I mean, by default, what John the Ripper is doing is it is looking at its own password plain text file. and then comparing it to the hashes out there. Are there better word lists that we can down? Just exactly, frog, this is exactly what I want to get to next. And I want to introduce you to Seclist. Seclist is a project public that is created by my friend Daniel Meisler. Now what Seclist is, it's a security tester's companion. It just contains a collection of lists that are used during security assessments. Username, password, URL, sensitive data pattern, fuzzing payload, web shell, you name it. The list goes on. And on my system, I always make a copy of Seclist. Clone it. Okay, want to give a shout out to Daniel and Jason. The entire repository is over a gigabyte, so it's a lot of data. But if you can take a look at, now there's AI and LLM testing. Cool. Fuzzing. Miscellaneous. Here it is. Passwords. Here's a list of all the password files. All the passwords list that you can find. Oh, lots of passwords. Alright, hold on. I'm gonna go CD repos, CD seclist, CD passwords. See what we got. Damn it. There we go. One of my favorites is, this one is easy. This is X-Acto net 10 million passwords. Let's say 10. These are I think these are top 10. Then you can do top 10,000. There you go. Okay. Let's do a word count. Yeah, this is 10,000. How about this one? This is 1 million, the X-Acto 10 million one. Oops. Is that a million? No, X-Acto a mil. More X-Acto a mil. Yeah, that's 1 million. My favorite one is Dark Code. Why is this one? Dark Code had 1,471,056. Okay. There's a whole bunch of password lists here. If you do more Dark Code. Woo! Woo, woo, woo! Yeah. The best way to crack password by far and away is to use wordless. So, damn it. How about days? What's days.txt? Ooh. Even got that for days. Let's go this one. Let's use the 10 one. Okay. So let's go back to my desktop. Let's go back to the home directory. And let's run John the Ripper again, but this time using a word list. This is how you crack with word lists. So is John crack me, let's go John, the crack me file, minus format. On Mac OS, when I crack $1 and $6 password, I don't use the format option at all. But I do use the word list. So all you need to do is minus word list equals the path to the word list. Okay? If I hit the enter key, watch what happens. It's just going to go through all 10 passwords, and once it's done, it's done. Hey, CISO Global. It's a status symbol. Yeah. Here's the thing is, here's the thing. Why I don't teach Hashcat in this class. Hashcat, if people swear by it. Like, people swear by Hashcat. People swear by, I think that was it. I think it just went through, I think it just, yeah. I think it's, wait. Yeah. Wait a minute, hold on. Oh, I used a full 10 million one. I don't want that one. I want the 10 one. I just want the 10. Yeah, the 10, here it is. The word list with 10 is like tiny. I mean, that just, if I do the 100 one, it's also going to be really quick as well. 1,000. That may take a while. Yeah, that was done quickly. 10,000. That could take a little bit. Yeah, John. Okay, here's the thing. John Jumbo did not come with Unshadow on Brew. It does. You have to find it. But here's the other thing. I already unshadowed everything for you, so you don't need to run Unshadow for the password cracking competition. SoCal_Nilla. Um, I don't teach Hashcat because for years Hashcat didn't work on the M1s on the Mac. It didn't. The other thing is, again, I'll say this again. Teaching John the Ripper, using John the Ripper forces you to understand /etc/password /etc/passwd. So you have to understand both the shadow. You have to use both the shadow and the password files to use John the Ripper. You can get away with not understanding that using Hashcat. But yeah, primarily Hashcat never worked for the longest time on Mac OS for the newer Macs. Okay. I'm gonna cheat now. Okay, I'm gonna vim cheat.txt. I'm gonna create a file that is just one word. Oh, 2 lines, including the new lines character, the return. So I'm gonna do John crack me, but the word list is going to be cheat.txt. Yes, you can create your own word list, and watch what happens. Worst student password or daisies123. There you go. But by far and away, use wordless. By far and away, use wordless. Okay? Seclist is really your friend. Okay, Seclist is really, really, really your friend. I was like, what the hell? It's only 1% done. I was like, did I use the full password list? Did I use the big one? Yep, it did. But here's the thing. There is one moral of the story. The one moral of the story is, after today, is I want to let you all know it doesn't matter how long your password is. It doesn't matter how great your password is. As CISO Global said, yeah, you could build like it was a status symbol status symbol to build the biggest password list that you could. It's still the case. It's still the case. People still do that. It's still a status symbol. Okay, but um, the moral of the story is it doesn't matter how big your password is, how nice it is. At the end of the day, the moral is any password can be cracked, given time. So I want to show you this Reddit post that I absolutely love. And I think it's actually the time it takes has changed because computation power is really, really big, has improved greatly. So here is a table of how long it takes for a hacker to crack your password. So we have the number of characters, and the different columns are the type of your password. If you're using numbers only, if you're using lowercase letters only, combination of upper and lowercase characters, combination of uppercase and lowercase and letters and numbers, and then everything. So as you can see, If you're using numbers, I mean, let's say if you're using a password that is 18 characters long and it's just numbers only, worst comes to worst, takes like 9 months to crack them all. Lowercase letters, if you're using a 6-character password of just numbers only, it's going to be broken really quickly. Lowercase letters only, broken really quickly. 6-character password, upper and lowercase letters only, really quickly. Uppercase, lowercase letters, and number, 6 characters, not too long. Okay? So password length matters. The longer your password is, the longer it will take, for someone to crack your password. But as you can see from this table, it doesn't matter how long your password is. Your password will be broken given a matter of time. It could be 1 second. It could be 1 minute. It could be 1 hour. It could be 1 day. It could be 1 month. It could be 1 year. It could be 1 century. It could be a number of different centuries. It could be 100 centuries. It doesn't matter. Your password will be broken given enough time. Okay? We may be dead, in 100 years, but hey, again, passwords are all going to be cracked. So the other thing is, look at any password can be cracked. I mean, if you're using like a small short password or a dictionary word, you're just asking for it these days. The only way you can really, really defend yourself is to use a good password manager and two-factor authentication. Okay? You always assume that someone's going to have your password or your password is going to be cracked. You always assume that. No matter how long your password is, no matter, So, the only proper defense, is to use like two-factor authentication, where even if someone breaks your password, you gotta have like a code that is in your possession, usually on your phone, in order to actually gain access to the account. Okay? Any recommendations on password manager? Yeah, I mean, look it. Look. Hey, it's time to ban. I got 2 people to ban. Look at that. Hooray. Alright, any password manager. Well, now Apple iOS 18 has a built-in password manager. That alone is a starting point. There's no excuse to not use a password manager now. Or two-factor authentication for that matter. That's built in to Mac OS. You can use the password app. That's free on iOS 18. LastPass was broken. 1Password has been broken. LastPass is just a joke. I mean, that's just becoming a gift that keeps on giving. I use Bitwarden because it's platform independent and largely open source. Bitwarden. Okay, and it's like, what, $10 a year if you use the cloud option. Yeah. Platform independent. Alright, got everything that you need. User interface, it's not bad at all. You just have to get used to it. It's not bad. And largely open source. Okay? KeePass is the one. Yeah, KeePass, but yeah. I mean, KeePass is good. I mean, that's good too. But yeah, definitely a no-no for LastPass. No. And so, folks, that's it. The password cracking competition is now officially open. So here it is. Password cracking competition. 16 hashes. Alright, 16 hashes for you to crack. Now you know what? No $Ys. You can just run it straight without format crypt. Crack as many as you can. if you crack them all, you get an automatic A for the course, which no one has. Good luck with that. So, yes, happy National Cybersecurity Awareness Month. And yeah, happy hacking, everyone. It's time. All right, we are over time. Thanks a lot, everyone. Have a good weekend.